Alrighty, here is the law of cosine, and I still think of it in words, even with misspelled words right here. So kind of the structure of the formula is on one side of the equal sign we have one of the sides that is opposite the angle over there on the right where the cosine is. And then it's equal to the two other sides squared, added together, kind of the Pythagorean theorem part there, and then we subtract 2 times those sides multiplied, also multiplied by the cosine. And you can see it with the letters here, but if you just kind of understand the basic idea, then you're not having to memorize a bunch of formulas verbatim. And this one you can see there's a lot of moving parts here, so there are more variations on this formula than maybe the law of sines has. So just like before, we're given 3 bits of information. So we're either given all 3 sides, and we solve for the angle, or we are given 2 sides and the angle that's in between them. So we do not, the law of sine requires an angle and the side opposite paired and then something else in order to do that. But the law of cosine, we have 2 sides and the angle between them, and then we solve for that side opposite, and then we can figure everything else out. All right, let's take a look at an example. So solve the triangle. We'll just scroll down. We've got an angle and the 2 sides. So you see that even just based on the letters, we don't have side C. If we had side C, that would be the law of sines, and we'd have to follow it. But we've got A, B sides and angle C. That's the clue for law of cosine. And you can see I just went ahead and solved for the C and put the square root there. So the angle, we're told, is the indicator of what side we have to solve for first. And if you don't remember the letters, what we're doing here is the side we're solving for equal to the other 2 sides we're given, squared, minus 2 times those other 2 sides, times cosine of 45 degrees, big old square root over the whole thing. And then you just go right to the calculator and type it in. Like that. Now, one of my cautions, I didn't write it on the notes, but I talked about it and I posted it on Blackboard. If you use the law of cosine first, if you have to, if you're required to, it might be an option under some conditions, but we absolutely have to use the law of cosines to solve this first. Do not ever use the law of sine. You could, theoretically, and many students do, which is why I'm cautioning you. I don't want you to lose the points. I'm cautioning you, just use the law of cosine and nothing else. Don't even get to the last angle and subtract from 180, because if you did make a mistake, you'll still introduce that. I always do that with the law of sine. I have fewer students that make mistakes with it by itself, but the law of cosines, if you solve for the law of cosines first and then use the law of sine, you could create the ambiguous case. And I will have students that do that and then say no solution. Or they'll find 2 triangles. If you use the law of cosines, there is only one triangle possible. There is no ambiguous case for the law of cosine. So just use the law of cosines throughout. And now one of the things, let's just go through it. So we're given 2 sides to begin with. We solved for the 3rd side. Now we have all the information to solve for the other angles, and each time we do that is going to be independent. So if we have made a mistake, at the very end, we can take those 3 angles and go, oh, it doesn't equal 180. I made a mistake. So solve for angle B. You can see I plugged the numbers in here because I'm solving for angle B. I start with side B squared equal to the other 2 sides squared and added together, minus 2 times the other 2 sides, and then times the cosine B that we're solving for. I did a little bit of algebra here. You can do it, and this is just straight out of algebra. There's no trig in what we're doing here. The 15 squared is added, so I subtracted it. The 10.6 is squared, so I subtracted it. The minus 2 times 15 times the 10.6 is all the coefficient of cosine, so that whole thing gets divided. And you'll notice the big old parentheses I have around all three of those terms. When you go to the calculator and you'll do 10 squared minus 15 squared minus 10.6239 squared, and you could hit enter. And when you hit the divide by, you have to put that open parentheses. If you forget that open parentheses, you're going to get it wrong. You might not know you got it wrong. And then you might do a mistake in the third part if you ignore my instructions I'm about to give you. All right, so once you have that fraction typed in, you see the cosine inverse with whatever the answer is on your calculator. This is a plug and chug is what I hear students say. You plug the numbers in, you type it in the calculator. There's no other way. So the third angle, I am not going to subtract from 180. I'm going to do it with the law of cosines. So I am solving this angle independent of the angle B that I had. And if there was a mistake somewhere, then the original 45 and the two angles aren't going to be 180. And I mean, it could be 180.0001 or something. That's close enough. But if it's 177 or 200, you should double check that at the end. So if you do it this way, you're less likely to make some of those mistakes that I see students make all the time because they ignore me and do what they want. All right, let's try another example. And we got a word problem. Badly phrased here. What will be typed on the test will be a little bit better. Basically, we've got a tunnel. We've got one person standing off in the distance, and then we've got two other people standing at each side of the tunnel opening. So the survey person is looking at person A off to the left and takes a measurement, and then he turns his little device a certain angle, 82.4, to person B and takes a measurement. So we have the distance from the one person, the survey person, to the other two people, and we have the angle in between like that. And if you draw the diagram like I have here, it should law cosine. So we got two sides, angle between. What's the angle, the side opposite? Just plug it in, type it in the calculator, and you're done. Like that. All right, so that's the end of this video. Be sure to check out the other video where I will do a couple examples using bearing rather than just looking left and right like that. I'll just save that for something else. So let's just click stop.